My dear students, in this video I am going to discuss Maxwell Boltzmann distribution law. In the previous classes we understood kinetic theory of gases and its limitations, Van der Waals equation for real gases, adsorption isotherms, Andrews adsorption isotherm, critical phenomena we discussed. So the next important concept is Maxwell Boltzmann distribution law. This law mainly going to describe the velocities of the molecule, gaseous molecule. You would just look at the gaseous molecule which is randomly moving in a container. But in kinetic theory of gases, it explains some of the properties of a gaseous molecule. But the exact quantitative relationship between velocity and number of gaseous molecule is not mentioned in that theory. It is not derived. But based on the postulates of that theory, by keeping that assumption in mind, Maxwell and Boltzmann try to identify the velocity which is carried by the fraction of gaseous molecule. Why I am using the word fraction? Because if there are, assume that there are 1000 gaseous molecule which is present in the vessel, we cannot expect not all the 1000 molecule possess same energy and velocity. Probably around 100 molecule possess the velocity of 50 meter per second, and another 100 molecule possess the velocity of 100 meter per second, and another 200 molecule can possess 150 meter per second of velocity. So like this, so it is depends on the temperature, it is depends on the nature of gaseous molecule, the velocity and the energy of the molecule is varies. So this Boltzmann distribution law is try to explains the probability of distribution of these molecule into various velocities and various energies. And from this theory we can understand the distribution function, the most probable speed, the average speed, and root mean square velocity of a gaseous molecule. And we can also understand the moment of gaseous molecule and with the velocity v and vw, v plus dv. V plus dv means suppose the gaseous molecule is moving. When it is collided with another gaseous particle or with the walls of the container, the velocity is changes. The change in velocity, the increase in velocity is called as v plus dv. So before going to discuss, understand this Maxwell Boltzmann distribution law, so let us look at this graph, dear students. So in this graph, in the x-axis we have taken number of particles, and in the y-axis energy of the particles. So in the x-axis number, so in the x-axis energy, in the y-axis number. So now let us draw the graph of so number of particle versus energy. Now two molecules can carry 5 joules of energy. Here we express energy in terms of joules, and around 4 molecules can carry around 6 joules of energy, and 6 molecule can carry around 8 joules of energy, and here 8 molecules so can have an energy of 10 joules, and 10 number of molecules can possess 15 joules of energy, and around 11 molecule is going to possess 20 joules of energy, and around 9 molecules, you just look at it, this is 9. So you look at the point, you know how to the meaning of this point. So this is how the number of particles, so each point indicate the number and their corresponding velocity. So this is how the molecule possess different velocity. For example, in this zone, So around 2 number of molecules possess 50 joules of energy, 3 molecules possess nearly 44 joules energy, and nearly 4 molecules possess 35 energy. So this is how the velocity is distributed. These are the different velocities. So 1, 2, 3, 4, like these are the different velocity possessed by a different fraction of molecules. So if you draw the graph, so we will get a curve like this. We will get a curve like this. So if you join all the line, you will get a curve like this. So this is the curve we are obtained at temperature around 40 degrees Celsius. Now you understood how the velocity the varies with the fraction of molecule. That means, so if you consider in this zone, so the number of particles is 8 and their energy is 10. That is, so 8 particles, 8 number of particles, gaseous particles carries 10 joules per moles of energy. So now what I am going to do is I am going to increase the temperature. I am going to increase the temperature. I am going to increase the temperature. So now I am going to increase the temperature to 80 degree. If temperature increases, what happens? The gaseous molecule get kinetic energy. That is, the energy of the gaseous molecule increases. So at 40 degree, 2 molecules so carries 5 joules. Now it is increased that, so maybe 3-4 molecules carry that energy, and 6 molecules going to carry 12 joules energy, and 8 molecules before they carry 10 joules, but after increased temperature, so their energy is 15 joules, and here the energy is nearly 20 joules. So here like this, the energy increases. The energy of gaseous molecule is increases like this, and so if we join all these points, you will get a curve like this. You will get a curve. So this is the curve at 80 degrees Celsius, and this is the curve at 40 degrees Celsius. So now, so there is a variation in this curve. So you look at the area under the curve. So in this curve the area increases, and in this curve the area is less compared to this. And if you look at this area, extra area which is produced after increasing temperature, this extra area is the number of molecules. So their number of molecules and their energy is increases. So this area, it gives the quantity of those molecules. And if you look at this graph, if you come to this zone, if you come here, what happen? If you come here, so here energy, for example, from here, so the molecule possesses more than 30 joules, 35, 40, 45, so 50 joules of energy. In this zone, the energy of the molecule is high. But if you come here, in this zone, the gaseous molecule possesses less energy. So during chemical reaction, the molecule which is present in this zone, that is, the molecule which is possessing higher energy, they colliding with the lower energy particle to give reaction. So this graph is called as Maxwell distribution law. So that is this is going to explain the probability of distribution of fraction of molecule so into different energy. As I told in the beginning, not all the molecule cannot possess same energy. So some fraction of molecule possess so different energy. So that can be expressed by using a graphical notation. So this graph is called as Maxwell Boltzmann distribution curve. And this is a Maxwell Boltzmann distribution curve of number of particle versus so energy of particle. So now let us see that the mathematical expression. The mathematical expression is given by dn by n. dn by n is equal to 4 pi to the power of 2 by 3 into square root of m divided by 2 pi kt into exponential to the power of minus mc square divided by 2 kt into c square into dc, where dn by n is the fraction of molecules moving at velocity v plus dv, m is the mass of the molecule, kb is called as Boltzmann constant, and t is the absolute temperature. And so just now we draw the relationship between number of molecules versus kinetic energy. But if this kinetic energy is directly proportional to the velocity, if kinetic energy is more, the velocity is more. So now let us see the relationship between probability and velocity. Here probability is nothing but number of molecules. The fraction of molecules carry some velocity. Here the probability. So this is how the number of fraction of molecules going to get the velocity. So different velocity. For example, at this point Vp, so this is called as most probable velocity. Why? Because you observe at this point the number of molecules, large number of molecules possess this velocity. This velocity is around 380 meters per second. So this 380 meters per second velocity, so that is maximum number of molecule possess this 380 meter per second velocity. If you come here, what happen? So here number of molecules are less. Number of molecules are less in this zone. But here more number of molecules. So having this velocity is called as most probable velocity. That is the velocity which is carried by maximum number of molecule. It is called as most probable velocity. And this is called as VRMS. So root means for velocity, that I will discuss later. So this is the probability. So probability distribution curve of number of molecule versus velocity of a gaseous particle. So now this curve depends on temperature. If temperature varies, obviously the gaseous molecule get kinetic energy. As a result, the velocity increases. So in this graph, there are two curves. So one is red one and another one is green one. This red one is a temperature T1. For example, at T is, it is around 40 degrees Celsius. In the previous graph I explained. And T2 is around 80 degrees Celsius. So here what happened? So this is how, so the energy is less. So this is the velocity, maximum velocity of the molecule. So this is the maximum velocity. But if you increase the temperature, you just compare the number of molecules having velocity. So in this graph, it is, for example, if you take this is 100 meter per second and this is 200 meter per second. If temperature increases, the velocity of the molecule increases and the graph shift towards right and area of the graph is increases. So you look at compare the area of the two curve. One is red curve and green curve. The area of green curve is increases. The area under the curve. It signifies that more number of molecule possess velocity, that is increase in velocity, and you can observe the change in area. The change in this extra area is nothing but the molecule gains extra energy due to increase in temperature. So this curve explains the variation of temperature and with respect to the probability. And this velocity also depends on molecular weight of a molecule. It depends on temperature. If the temperature increases, velocity increases. And so this velocity also depends on the nature of a gases. That means the molecular weight of a gases. So you will just observe this graph. So there are four curves present in this graphs. These four curve corresponds to four gaseous molecule: helium, neon, argon and xenon. So in this case, we can conclude that the lighter gas particle move fastly compared to heavier gas particle. Here xenon is heavier. You look at first curve, the first curve, it is for xenon. So its velocity is around 200 meter per second, xenon. But if you take helium, the blue curve, so this is helium. So helium, the maximum velocity, or the most probable velocity is around 1200 meter per second. See the velocity of helium and xenon. Xenon just 200 and that of helium is 1200. It indicates that the velocity of a gaseous particle, it depends on temperature and it also depends on molar mass, molecular weight of a gaseous molecule. That is, heavyweight particles move slowly compared to the less weight particle. So this is how the Boltzmann explains the probability distribution curves with respect to